So let's think about the other stuff, the particulates. So basically the smoke portion. So fine particles, they actually have the kind of coal industry term for this material is called fly ash. So it's not ash down here, it's ash that is really fine and ends up in the atmosphere. And when you read about those folks and when it would rain in London and all of the black soot would come down out of the air, that's what it is. It's called fly ash. And it has its own economic, or it has its own kind of ecological impacts. One of the interesting things that we see is we have a significant amount of coal ash that will actually settle in places like Greenland. And when it does, it's sitting on these glaciers as like a black cover, and it's accelerating glacial melting, which I know your response to that is like, another bummer. But we'll hopefully get away from the bummers. But it's important to understand the bummers before we talk about how to avoid or what ways we can change them. So fly ash is a pretty big problem. One of the ways that we can solve that is we can actually put a series of slats, so electrically charged metal plates or slats, and that fly ash has to go through there, and they create static electricity, and it can actually cover those slats with that fly ash that's kind of continuously wiped off. So we can control some of that at the smokestack. But not all of it, right? We're better at it than we were, again, in the 1800s in London. It was just free-for-all, just let this stuff rip. And we don't really do that anymore. So the last problem I want to talk about with coal, and again, we could talk all semester about coal. It could be its own class, right? Depending on what part of the country you're in. If you go to school for geology in Wyoming, you're basically going to coal school. I have a few colleagues down there. And most of their students go straight into the coal world. But this problem, I think, is actually pretty interesting, and there's a couple of famous examples, but it happens all the time. And this is the problem of what we call coal seam fires. And so if for some reason, and this can happen lots of different ways, a coal seam is ignited. So remember, it has methane in it, and then it is the rock itself that burns. So as this coal seam, if this coal seam catches on fire, it can be a pretty big problem. So one of the best examples in the US is the town of Centralia, Pennsylvania. I'll give you a little YouTube clip of Centralia that you can watch. And what happened in Centralia, you shouldn't be laughing, it's a terrible story. But there was a fire at the dump, which I drew here. This is the DUMP dump. So there was a fire at the dump, and it's Pennsylvania, it's coal country, and essentially the coal seam caught on fire. And if you guys all think about it, fire needs a couple of things, right? It needs a fuel, and it needs oxygen, and an ignition source. So we got our ignition source. It is fuel. It's famously fuel. And it turns out, if the surrounding rocks are porous enough, like sandstone, there's enough oxygen and there's enough gas in those surrounding rocks that it will slowly pull gas in from the surrounding area and just kind of smolder, right? It's not a raging fire, but the fire in Centralia, and I'm going to say off the top of my head, I always get this stuff wrong. I think it started in the 70s. I always will put the correct year down here. So that fire started a long time ago. It's still burning, right? It's just still plugging away underground because there's nothing you can do about it. We can't go down there and get to it. It's thousands of feet below the surface. Again, Centralia, super famous example because the coal seam fire is actually under the town. And the town was abandoned, and I think there's still one or two more people that live there. And if you go to geology school anywhere in the area, you'll go to Centralia for a field trip and learn about coal seam fires. It's too far for us to go. So you can see here's an image of another example of a coal seam fire. They're not uncommon. There's hundreds of them per year, and some of them can be burning for a very, 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 very long time. And there's nothing you really see at the surface except for smoke kind of rolling up out of the ground. So smoke and also water vapor. So again, pretty nasty stuff. You get caught up in a coal seam fire. Enter the realm of politics. So clean coal, you'll hear about it on the news, you'll hear about it in speeches and politicians and all that stuff. The fundamental reality of clean coal is that it's a myth, right? There's ways to make coal cleaner, but coal is fundamentally the dirtiest of the dirty, and there's really no way around that. But like I said, we can make coal a little bit cleaner, so maybe I should kind of add that parenthetically after clean. So just imagine it says ER in some parentheses up there. So cleaner coal, and we'll talk about just a couple of things here. I don't want to spend too much time going through this because there's really a lot to think about. We'll talk about the most commonly used methods. We'll talk about a few experimental methods, but it's important to realize that there really is no such thing as clean coal. And we'll hopefully kind of talk about how each of these things can make coal a little bit cleaner. This is the smokestack, right? If we go back to our power plant, it looks, or not our power plant, excuse me, our furnace. It looks like this, and remember that all of the volatile portion goes up and out the smokestack. The biggest problem with the smokestack, again, is the gas component, right? So we've got CO2 pumping out of this thing, chugging. The biggest source, the largest source of CO2 that we have. Then the other stuff that we talked about, what was a problem in this case, was fly ash or aerosols or particulates that come out as well. And so we basically put these electrostatic precipitators, and basically they are like metal fins. If you've ever seen, what's that company? You can sometimes get an ionizing air filter that works the same way, where it's just metal slats, and they're charged, and as air is forced through, all of the particulate matter will stick to them. So this would be one of those slats. That solid particulate matter would stick to it, and it can be cleaned off. And sometimes they have like a little machine that cleans it off, kind of in a never stopping sort of way, and that can reduce the fly ash or the aerosols that come out. So the thing to always think about in the case of clean coal is we still have, this doesn't have anything to do with the CO2 that's coming off of this smokestack, right? That's still a pretty big problem. The next way we're going to make our coal a little bit cleaner is to scrub it, or at least scrub the gases that are coming off it and the particulate matter that's coming off of it. So again, that's the problem, right? We're not really dealing with coal ash here. We're talking about the emissions that are coming out of the smokestack. So, kind of just like a crummy drawing here, but we'll take a look at some better drawings. But I drew our standard furnace, right? So this is where the coal is burning, and the gases are coming out of that. And then, so rather than going out directly into the smokestack, as we saw before, they go into this intermediate cylinder, and they rise up through that cylinder, and then ultimately the gas comes out the top. But the hitch and the giddy up is in that cylinder. There's basically a small, similar to a sprinkler, that contains actually some very specific chemicals that will interact with sulfides and all of the stuff that we really want to avoid. So as this gas is rising through our scrubber, it's rising through like a mist of water raining down on it, and that mist of water will grab some material and settle that to the bottom. And then the next problem is now you actually have a new waste product, which isn't necessarily coal ash like we had here, but it's concentrated fluid that contains a bunch of dissolved stuff that was as kind of particulate matter, but it doesn't necessarily stop CO2. It primarily actually will react with the sulfides. So remember, again, the iron sulfides, the pyrite that happens to be in coal really often. And so this is taking those sulfur compounds, which are a big pollutant, but concentrating those But again, the CO2 is still coming out of the top, right? We haven't done anything to address that at this point. So here, this is a much better diagram than I drew of how one of these coal scrubbers actually works. You can see as the water comes off, or the gas and particulate matter comes through, it's sprayed out and then released to the smokestack. And then in this next feature, this next image, you can actually see them in real life. Right? This particular smokestack has 3 scrubbers, and then those big pipes you see running across the top horizontally into the main smokestack. That's essentially the cleaned gas that was brought in through these square kind of ducts that you can see coming in. Right? So that's the general pathway of flow. Coal washing, the third one that we'll talk about, and this is exactly like it sounds. You wash the coal. So basically we get a giant tank of water to do this. So hopefully you've started to realize some of the costs for these things are pretty ridiculous. So once we've pulled off this iron sulfide stuff, this pyrite, we then have the remnant is this powdered or kind of sand form coal, but it's, again, little tiny particles. But the heavy elements and the heavy metals have actually been stripped out by gravity, right? We just used the wonderful force of gravity here. And you can repack that into bricks and then use those bricks or those little chunks in our furnace, and they're not going to produce the sulfur dioxide that has been such a problem. So it's a pretty high cost. The reality is nobody's doing this on an industrial scale, although there are definitely some experimental places where we do coal washing. But no major coal corporation has taken it upon themselves to wash the coal and reproduce the bricks before they do it. The cost is just way too high. The other thing that we also know now is that the cost of coal generally is much higher than other forms of energy at this point. Natural gas is way cheaper than coal, cleaner than coal, and if you start looking at things, this even makes coal like triply expensive because you got to do all this process first. So there are kind of 2 other techniques. I'm going to leave them out because they're really kind of chemical situations on how we control what's happening in the furnace, so we can add gases that it will burn with. But generally, the take-home message is that these 3 types of clean coal don't really solve the problem of coal, although they do solve the problem of sulfur in coal, but they don't solve the problem of coal burning and producing CO2 in the first place, which is fundamental. So this is going to be the last video that we'll watch of the week. We left all of the politics and the coal production stuff on the table. We're going to come back and grab that in the beginning of week 9. Which is going to be the week that we talk about natural gas. And actually, natural gas isn't going to take up too much time. It's because we don't have to talk so much about the formation, the geological conditions that produced it. So we'll hit up the last kind of political side and production side of coal in week 9. Okay, well, I'll see you then. Bye.